All right, let's look at the homework 9, problem number 29. All right, so derivative of the function n is given. Then what we want to do is we want to find the minimum value of dn over dt. All right, so let's do that first. All right, so we want to find the minimum value, so we need to take another derivative. So we take the derivative. So there'll be a second derivative with respect to t. All right, so this is going to be, all right, so we have a negative 3,000. So that's just a number, so I'll just put it right in front. All right, then use the quotient rule to take the derivative. All right, so we've already taken care of this guy. All right, so square the bottom, which is 1 plus t squared, quantity squared. All right, derivative of t is 1 times the bottom, 1 plus t squared, minus top is t, times derivative of the bottom is 2t. All right, so if you clean this up, you're going to get, all right, so negative 3,000. So I'll just leave that. Then you're going to have 1 minus t squared minus 2t squared, so it's going to be t squared over 1 plus t squared squared. Right? So we set this guy equal to 0. We get, let's see, we have to make 1 minus t squared equals 0, so it's going to be t is equal to t squared equals 1, so plus or minus 1, right? But in this case, t is between 0 and 9, so we only take the positive 1, so positive 1 here. All right, so that's the critical number. All right, then let's make sure that that's going to give you the minimum, because it could be the maximum, right? So we're going to look at the, going to do the number line again. So here, and 0 and 9, because t is limited between 0 and 9. And critical number we found is 1. So I put 1 here. All right. So let's try any number between 0 and 1. So I'll try 1/2. All right. Then after that, I'll try 2. All right. Then let's look at the sign of d squared. Second derivative of n with respect to t. All right. So if you plug in 1/2, so it's 1 minus 1/2 squared, so that's positive. It's going to be negative because of the negative sign. So it's negative here. And if you plug in 2, 1 minus 2 squared would be negative, but there's a negative sign, so that's going to be positive. All right, so if you look at the graph of dn over dt, we know that this is going to be decreasing here, after that increasing. So that will guarantee that we're going to have a minimum here. All right, so which is good. All right, so when t equals 1, you're going to have a minimum value. So let's say, okay, so minimum value, oh, we have to find a minimum value. All right, so we have to plug in t equals 1. So dn over dt evaluated at the t equals 1 is going to be negative 3,000 times 1, so it's just 3,000, and 1 plus 1 squared, so it's going to be 2. So it's going to be negative 1,500. Right? So let's type that in. Let's see, we got negative 1,500. All right, check the answer. All right, we got that. All right, if the initial count was 8,000 bacteria per millimeter, find the n of t. Then find the bacteria count after 9 days. All right, so let's do that. All right, so it says that n of 0 is equal to, oh, I forgot the number, 8,000. All right, so 8,000. then we want to find n of t. All right, so let's do that. So since derivative is given, so we can just take the antiderivative to go back to the original function. So if you want to find n of t, all we have to do is find the antiderivative of negative 3000 t over 1 plus t squared with respect to t. Alright, so let's use a substitution here. I'm gonna let u be this denominator, 1 plus t squared. Alright, so this guy right here, we're gonna call this guy u. Alright, go through the usual drills. Take the derivative of u with respect to t. You're gonna get 2t. And I'm going to solve this, so take the reciprocal of both sides, dt over du is equal to 1 over 2t. Then I'm going to multiply by du to get the dt by itself. So it's a du over 2t. Alright, so after substitution, we can get the integral. Alright, so negative 3000. Alright, I'm going to leave t here, alright, but we decided to call the denominator u, and dt can be replaced by du over 2t, alright. So we can cancel, right, t, and actually 2 and the 3000, so it's going to be 1500 there, alright. So we have, so this is going to be negative 1500. This is just a number, so I'll just leave it outside, and you would have 1 over u with respect to u. Right? So the antiderivative of 1 over u would be natural log of absolute value of u plus some constant c. Right? Then if you want, we need to put the original variable back in. Remember that u is the same thing as 1 plus t squared. And we don't have to put absolute value because 1 plus t squared is never negative. All right, so we have that. All right, then using the initial condition up here, n of 0 is 8000, right? So use that to find this c here, right? So n of 0 is equal to, right? So you can see that the natural log of 1 plus 0, so natural log of 1 is actually 0, so you're just going to get c. So c is actually 8000, right? So therefore, n of t is simply negative 1500 natural log of 1 plus t squared plus 8000. Right? So let's plug it in. Right? So we found that to be negative 1500, and the natural log of 1 plus t squared, and then plus 8000. Alright, let's check the answer. Alright, we got that. Alright, and we want to find this after 9 days. So we have to round it to the nearest whole number. Alright, so let's do that. Alright, so we have 9, so we just need to find the n of 9, which is negative 1500, right? Natural log of, right, 1 plus 9 squared. So 9 squared would be 81, so it's 82, plus 8000. Right? Let's pull out the calculator, right? And let's see, I'm going to move it so that I can see what I have here. All right, so we have negative, right, 1500 times natural log of 82, and plus 8,000. Right? So it came out to be 1380, actually 1390. Right? So let's type it in. All right, it came out to be 1390. All right, let's check the answer. All right, we got that. All right. All right, and when is the bacteria count of 5,000 per millimeter? All right, so we just have to set the function to 5,000. All right, let's see, 5,000 was it? Let's 5,000. All right, let's solve this equation. So n of t is negative 1,500 natural log of 1 plus t squared plus 8,000 is equal to 5,000, right? So first I'm going to subtract the 8,000 from both sides. So you have a negative 1,500 natural log of 1 plus t squared is equal to negative 3,000, right? Because 5,000 minus 8,000, right? Then I'm going to divide through by negative 1,500. So we get natural log of 1 plus t squared. All right, 3,000, negative 3,000 divided by negative 1,500 would be just 2, right? Then we can raise e to both sides. So if you raise e to the natural log, cancel out, you get the 1 plus t squared is equal to e squared. All right, then we can subtract 1, so t squared is equal to e squared minus 1. Right, then we can just take the square root. So t is equal to plus or minus square root of e squared minus 1. Right, but since we don't want to consider a negative time, so it's going to be just a positive guy. All right, so let's compute that value there. All right, and all right, we just need to compute, so we need a square root here, right? And then you have e to the, let's see, where's the exponential function? Here's e to the squared, all right? Then minus 1, right? Hit enter. All right, it's 2.53 about, let's see, what do we need? All right, and nearest the 100th as needed. So it was 2.53. Right, 2.53 days. Let's check the answer. All right, we got that. All right, that's it. I hope that this was clear.